Hi everyone. In this video I'm going to be covering how to complete question 7 from the practice tips questions for Unit 2. Okay, so in question 7 we have to find, it says here, the arithmetic mean of two positive numbers is 1/2 the sum of the numbers. So the arithmetic mean, that's the formula for it. Arithmetic mean is basically what you probably know as average, right? You just take two numbers, divide by 2, and that gives you the average, or the arithmetic mean. We also have something called the harmonic mean, which is you take two numbers and you take the reciprocals, and it's the mean of their reciprocals. So and it's the reciprocal of that, basically. So you take two numbers and you flip them, you add them together, find the mean of that, and then take the reciprocal of that, and we call that the harmonic mean. Okay, so we have to do two things here. We have to show the harmonic mean of 5 and 7 is 35/6, and show the harmonic mean of two distinct positive numbers, a minus x and a plus x, is always less than the arithmetic mean. So this is the real question. This is kind of just to warm you up here. Okay, so we have 5 and 7, and we're going to plug them into our formula. So that's what we do here. We put in 5 and 7, so raised to the exponent -1 each. Remember that when you raise a number to the exponent -1, you flip it, or you do 1 over that number. So that gives us 1/5 plus 1/7. So this is kind of just normal adding fractions, right? We find a common denominator. So in this case, it'll be 35. So if I multiply this 5 by 7, I multiply the top by 7. If I multiply this 7 by 5, I multiply the top by 5 as well. Okay, so then we end up with 7 plus 5 over both numbers over 35. Since we have a common denominator, we combine them, and we get 12 over 35 divided by 2. I kind of like to write my fractions like this, because sometimes it can be hard to keep track of like what divided by what, and what do I flip, and which number goes on top and which number goes on the bottom. So if you make that little divided by 2 sign there, then it becomes, that's very easy. You just flip that to 1/2 and multiply. You can cancel that 2 and that 12. So the 2 becomes a 1 and the 12 becomes a 6. So you get 6 times 1 on top and 35 times 1 on the bottom. So we get 6 over 35. But remember that the harmonic mean is the reciprocal of all that stuff that we just did. So all this is raised to the exponent -1, which means you have to flip it. And so our final answer is 35/6. Okay, so very procedural kind of question. Here's where things get difficult and get interesting. So we have to show in part B that you have two numbers, a minus x and a plus x, and that both of those numbers, whatever they are positive. We want to show that if you take this mean, the harmonic mean, that the number will always be less than if you take the arithmetic mean, this mean. So, okay, how do we go about doing that? Well, let's try and visualize the problem first. So let's think about what this might look like on a number line. So I've said that a is here at 6. A does not need to be 6. A can be a lot of different numbers. But a is between two numbers, a minus x and a plus x. So if you start at a, which is somewhere on a number line, and you go a certain distance on one side of the number line, so we call that distance x. So if we go in the negative direction, then we're doing minus x. So in this case, maybe x is 3. You go 1, 2, 3. So this would be a minus x. You're a distance of 3 away from x in the negative direction. And you can go a distance 3 away from x in the positive direction. So again, we don't know what a is or what x is, but this is the kind of visual arrangement that we have. So what you can see then is a minus x and a plus x are both positive numbers, and a is right in the middle. So what that means then is a is positive, because a minus x and a plus x are positive. That's what the question tells us. So that's going to be important later on to know that a is positive. Okay, so we don't really know what we're doing yet with these formulas, so let's maybe try and simplify them a bit, and maybe we can come up with some kind of answer once we do that. So the arithmetic mean, we're going to put both our numbers, a minus x and a plus x, into the formula. So we get a plus x plus a minus x over 2. Okay, so we do a little bit of simplification there. The two x's will cancel out. Your two a's will add together to give you 2a, and so your mean is a. And if you look at the picture, that really should make sense, right? The mean is the middle of two numbers if you only have two numbers. And so a is right in the middle. So yeah, that makes sense. Okay, so we're going to do the same thing for the harmonic mean. So again, very procedural, kind of long, but it's basically the same thing that we did here in this case, just now we got some variables in there. So we put our two numbers in there, a minus x and a plus x, both raised to the -1. We flip them, same as before. We find a common denominator, same as before, and then we just, since we have a common denominator, we put the two tops together. So since I just have a 1 on there, that'll just be a plus x, and since this is just a 1, that's just a minus x, right? That's not going to change. So we're going to add a plus x and a minus x on top. So again, the x's are going to go away, and we're going to get 2a, which we can see there. And then we have to divide what we just got on the top. We have to divide that whole thing by 2. And we can't forget that we have an a plus x and an a minus x in our denominator. So this whole thing, both the top and the bottom, will divide by 2, which we can see here. That means multiply by half. Okay, so then my 2's are going to cancel out, and I'm going to get a over a plus x times a minus x, all raised to the negative 1. And then we can flip this, and so we get a plus x, a minus x over a. And so this is where you're likely to get stuck, because, well, what do we do with this? Okay, I know my arithmetic mean simplifies to a, and my harmonic mean simplifies to this, but how do I show that this number is always less than a? Well, we got to play with it a bit. This is where the thinking part comes in. We got to be really kind of creative here. So you might notice that the top is, you can expand it. It's just the reverse of a difference of squares. So you're going to get a squared minus x squared on the top. So the trick here is what you got to do is you got to split this up into 2 fractions. So the way that you do that is you keep the denominator the same. So you have a squared over a minus x squared over a. You split it up. And you can do that. If that looks a little bit weird, you are allowed to do that, because think, once you get to this step, you have a common denominator. It's very easy to see how you can go from this to the step above, right? Since you have a common denominator, you can just put a squared minus x squared on top over 1a. But you can also split them and put this over 2a. If you do this, then what's going to happen is the first section here, your a squared over a, is going to simplify to a, and the second section is going to remain as negative x squared over a. So let's think about this x squared over a term for a moment. Okay, so we know that x squared must be a positive number, because if you square any number, it's positive, right? Whether you have a positive or a negative number, if you square it, then your result will be positive. The only case is when x equals 0. Okay, so if x equals 0, that's not true. But if we look at our question, it says that it's a harmonic mean of 2 distinct positive numbers. Distinct means different. If x is 0, then you don't have 2 distinct positive numbers. What you would have is a and then a again, right? If I have a minus 0 and a plus 0, both of those just give you a. So x can't be 0. That's so we don't have to worry about that. So x can't be 0. If x is negative, when you square it, it becomes positive. And if x is positive and you square it, it's also still positive. Okay, so basically x squared is positive. A on the bottom. Well, we already said at the beginning of this problem, and we said it was going to be important, that a is positive. We know that because a is in the middle of 2 positive numbers, a minus x and a plus x. So it's positive. So what that means is, with this term, x squared over a, what you've got is a positive divided by a positive. So this whole thing, this x squared over a, this x squared divided by a, is a positive number. So now we got the answer, because our arithmetic mean is just equal to a. And our harmonic mean is equal to a minus a positive number. Well, if you take a positive number away from any number, you're going to get a smaller number, right? If you subtract a positive number from anything, your result will be less than what you started with, whether your number, no matter what your number is, right? If I have 5 and I subtract 3 or 2 or whatever, I subtract a positive number from it, I'm going to get a number lower than 5. So we've solved the problem at this point. So we can say if you subtract a positive number from any number, which we'll call a, so if you subtract a positive number from any number a, the resulting difference will be smaller than a. Okay? So therefore, since the harmonic mean is that, right, the harmonic mean is a minus a positive number, and the arithmetic mean is a, that means the harmonic mean will be less than the arithmetic mean for any positive values, a minus x and a plus x. So we've proven it. Okay, that one's a little tricky. I guess you could call it a mean question. Have a good one.